Welcome to the SNMP Southbound plugin presentation. In the previous videos, we have talked about MIB to YANG conversion and related applications. In this video presentation, we are going to talk about the SNMP Southbound plugin. We are going to explain how to interact with the plugin and how MIB and YANG models are uploaded to MD-SAL and assigned to devices. Before the demonstration, we will take a look at our testing setup. And finally, the demonstration itself, which will be divided into two main parts. The first part will focus on device management and device content access, and the second part will focus on traps and their processing by SSB. At first, we need to clarify how SNMP devices are managed and how their content is accessed. In this diagram, some components of MD-SAL are shown. For now, we are interested in two of them. The first one is topology-SNMP, which is special topology in the network topology model. This is the default name, but it can be changed through configuration. This topology holds nodes, and every node in this topology represents one SNMP device. To be able to recognize this node as an SNMP device, it's important that this node has specific augmentation, which is specified in the SNMP Southbound plugin's YANG model. This augmentation contains parameters like IP, credentials, etc. One very important thing is node ID, because the same ID, or better, YANG instant identifier, is used to retrieve the Mountpoint representing our SNMP device from the DOM Mountpoint service provided by MD-SAL. This Mountpoint is then used to access device content and retrieve traps as DOM notifications. So in short, through topology-SNMP are managed devices, which means nothing else than adding them, removing them, retrieving their status and other information, while the Mountpoint is used to read and write content from or to an SNMP device. And they are bound together by ID, which is the same for both the node in topology-SNMP and the node's corresponding Mountpoint. This is the basic concept of how our SNMP device is represented in MD-SAL. In this communication diagram, a very basic interaction with the SNMP Southbound plugin is shown. This example is based on the fact that the device is reachable. So let's go through this diagram. From the user point of view, only steps 1, 8, 9 and 10 are important. The remaining steps happen automatically and are done by the SNMP Southbound plugin. In the first step, we have written a new mode to topology-SNMP. This fires the event, which is received by the SNMP Southbound plugin. Based on this, SSB tries to connect to the device and after successful connection, creates the Mountpoint, registers it, and sets node status to connected. After this, the user can retrieve Mountpoint and perform read and write operations, and of course, receive traps. This is how we basically interact with SSB. In this diagram, our testing environment is shown. It's composed of 4 virtual machines. 3 of them are Debian Linux machines. On these, our ODL distribution will be running. Plus, on the first one, also the net SNMP will be running, which will be our second SNMP device. The 4th virtual machine is the Cisco Virtual Switch, and it will be our first SNMP device. All virtual machines and our PC on which we are testing are together interconnected through a virtual network. Part of the SNMP Southbound plugin is support application, and its purpose is to aid the robot framework by providing additional information that can't be retrieved through REST-conf. Information like Mountpoint type, publish notifications, and low-level cluster state. For packet capturing, Wireshark, PuTTY for accessing Karaf console, and of course Postman for accessing data store and Mountpoints through REST requests will be used.